I can't believe we are 20 episodes in already. Thank you so much for joining us. I'm RK, Ravi still sorting out his issues in Bangalore. This is Code Space, and today let's trace some routes. Hey, so the idea that I have today is that we perform a trace route. The trace route will return me a list of IP addresses, the IP addresses that it has used to travel around the world. So these are routers that are located around the world. I take the latitude and longitude locations of all of these routers and I put them on a map that more or less looks like this. So this is the map that I have today. So I reside over here somewhere in Chennai. And if I was to, let's say, hit a server in California, which is, I think California is here. So let's say if I hit a server over here. So what needs to happen? So what will happen is that there are routers along the way, all the way that connect me to the server over here, right? So essentially all of my requests will perform hops across all of these routers before they reach their destination. That's what I intend to do today. So let's map out, I have this map, and what I intend to do is that on this map, I'll draw all of the lines that my connection has taken to reach its server. This can be applicable to any server that is located anywhere across the world, right? It can be within India itself, it can be in the US, it can be in the Europe, Africa, anywhere. So let's see how I intend to do that. But before we do that, I just need to make sure that I make a few things clear over here. This is a very simplistic model that I have of the trace route thing that we were talking about. So when you perform a trace route is a command that is available on Windows, I think by default, but on Linux, you need to install that package. I already have that installed. It's a very simple installation. So once you have the traceroute installed, you can perform a traceroute command and it will tell you the IP addresses of all of the routers that it hit along the way to your destination. So if I hit youtube.com, so one time it might say that your connection was established along this route. And another time it might just say that your connection was established along this route. That's the whole, that's what the internet is all about, right? I mean, it's about having this fallback thing, or what's the word that I'm looking for here? The internet is actually so strong, or it's so error redundant, that if, for example, if this connection was gone, or if a router along this way, along this particular route was disconnected or something happened, your packets will still find a way across to you along this route. All right. This is a very simplistic model. There are many ways packets can actually get to you. And in fact, even for a single file, they're all divided into packets. It is not guaranteed that they would all make on the same route. They could all arrive on different networks onto your computer, and then they're assembled, on your local machine. So, so before we go on with this, let's just at a very brief level look at all of the protocols that are involved over here. Now there is the TCP protocol. All right, this is the protocol that you are most used to. You do anything on the internet, TCP is 100% involved. What does TCP offer you? It offers you accuracy over speed. All right, this is the protocol that makes sure that all of your emails have no errors, all of your websites are rendered correctly, there are no lost packets, you suddenly don't have, half of the content missing and all of those things, right? So TCP ensures that all of the packets that have left the server are 100% delivered to the destination, and that they are all in the correct order. All right, so that's TCP, accuracy over speed. It's like a registered post that I'm showing, that I've put over here. There is the UDP, that's the user datagram protocol. And what happens is, if you don't value your accuracy, but you value speed in things like VoIP calls, UDP is the one that is most likely used, all right, where you actually want the information to go in any manner to the destination. So accuracy is lost a little bit. So if you've ever been in conference calls with clients, let's say anywhere in the Europe, US and all of those things, and if you suddenly don't hear them, it's because UDP is probably involved. And the third kind of protocol, which is primarily used only to test routers or to test the existence of of an endpoint or something like that, that's where the ICMP protocol comes into play. This is the Internet Control Message Protocol. It cannot carry any data. It doesn't have any packets as such, but it's simply meant to sort of, probe routers or computers along the way. They are generally used for these ping commands that you do, and for trace routes. All right. So let's just look at what a ping looks like. So if I was to say ping www.codespace.site, you will see that it performs a ping. All right. A lot of people will tell you that ping actually stands for Packet Internet Gopher, but that's actually a backronym. It's not an acronym. The ping was, I believe the word ping came from those sonar pings that submarines used to do. It doesn't have an acronym, or it doesn't come from an acronym. It's actually a backronym, wherein the meaning of the acronym was formed after the word was created, after the ping was created. So this is essentially just to say that codespace.site exists, all right? And where it doesn't exist, and not only does it exist, it says that the server is active and we are getting ping replies back from it. So I could say something like ping youtube.com, and you can see the IP address and everything that is listed over here, all right? And that the server is active and all. Whenever you do an ICMP call, such as ping, like I said, your ICMP protocol doesn't have any packets, or it doesn't have any data, but it has some very nifty parameters. It has something called as the time to live parameter. Okay, time to live is essentially saying that when you hit, let's say codespace.site or youtube.com, take these many steps to reach that destination server. All right, that's what it essentially means. Now, if I was to set that time to live for 1 at 1, it would only mean that it would only go to the next available router or the server. That is, it would only hop once before it reaches the server. That's what that means. Which means that that the ping can be modified to perform as a trace route. All right, where what I can do is, if I wanted to perform a trace route, I will take, I will perform a ping to this one, and I'll give the time to live as 1. Time to live as 1 means it'll hop over once, and then the message dies, and then it reports back saying that I have hit this server. If I say time to live is 2, then it hops once, twice, and then it comes back. And along the way, it will report the IP address of the last server as it hit. So pings can be modified with the time to live parameter to return all of the routers along the way. Okay, let's look at how the traceroute works. So I can, in Linux, I can say traceroute -i. The -i option forces the ICMP protocol to take place. Or else it does it either way at TCP and UDP, which I don't like. So if I said youtube.com, you will see that these are the servers that it hit along the way. So this is definitely mine, right? This is definitely mine. And then this probably hit a Hathaway router somewhere in Mylapore. I'm not sure where it is. And then all of these, I know this one is in Maharashtra. So it hit Maharashtra, and then it went over here, and then all of these servers. All right, so YouTube is at this location, and then this is my server. This is my local server somewhere over here. So I can do something nifty over here, right? Like, for example, I can look at IP to location, and I can say, this is not what I was looking for. So let me just do a proper Google search, IP to location, which means, so what this can do is, all right, is this the one that I was looking for? I'm not sure, but let's look at this. So let's say I do this one and I say locate. So this will tell me that this is at Chennai, Tamil Nadu. Okay. Remember how I was telling you that this is probably in Maharashtra. So if I did this, and if I said locate, you will see that this says Maharashtra. I know this because I've done this several times. All right, so this is Maharashtra. And then finally, let's look at the destination address, and let's put it on an IP address, lookup once again. So when I do this, it tells me that this is in California, Mountain View. I'm not sure where it is, but we'll just say this is California. Now, if I was to actually put this on a map, it would be beautiful, right? I mean, I'm in Chennai, Maharashtra, and then over here. Of course, along the way, it probably bounced off some servers here in New York and things like that. But you can see that if I was to draw a line, it would form like a very beautiful trace route on this map. That's our end intention over here. All right. So we already have many pieces of the puzzle with us. Let's look at what we need to do today to perform that trace route over a map. So first things first, I mean, we've already seen the trace route. We need a way to perform trace route in Python. And very fortunately, we have a library here called as the ICMP library, which is pretty neat. It'll give you exactly what you want for performing a trace route. The next thing is we need to perform an IP address to latitude and longitude. All right. So now there are many services on the internet that will allow you to do that, that will convert a geolocation into an IP address. But what I want, I'll tell you what I have done. All right. So once I have performed the latitude, so some of the sub steps that I need to do is convert the IP address to a long integer and then look up these values into a database. What do I mean by database? Now, a very long time ago, what I did was I went to this IP to location site. Let me just, so there it is. So I have that window already open. So I went to this site and I downloaded a CSV file that gave me a list of all of the IP addresses and their latitude, longitude. All right. So this is a CSV file that I downloaded, and this is what it looks like essentially. So it's just a list of IP addresses start and end, and then it gives you a latitude and a longitude. All right. That's essentially what this CSV file had. I took this CSV file and I loaded it into my database that I host on my server. All right. So we'll just do a very simple query of this database, and you will see that I have this database loaded. Now, why do I have it loaded as a database? So that I can perform a select query and just get a simple, location, just get a simple latitude and longitude. So if I was to execute this query, you will see that it returns me a latitude and longitude. That's the intention over here. What do I do with this latitude and longitude? Of course, let's just go back over here. I need to convert those latitude and longitude into X and Y pixel values. Why pixel values? Because this is an image, and an image has pixels and all of those things. So I need to convert X and Y into pixels, and finally just draw lines over the image connecting the locations. That's all. That's all I need to do. All right. So first piece of the puzzle, let's do this trace route. How do I do this trace route? I was talking to you about a library. This library is called as the ICMP library. I just installed it using the PIP3 installation toolkit. And once I did that, I was able to it's installed on my Python installation and everything. And this has very neat functions. So for example, it has the trace route function, which I'm the most interested in. So let me just scroll over there. So I have the trace route function, and this is how you perform a trace route. All right. It returns you something called as a hop object, a list of hop object. What is the return value? Let me just expand this a little bit over here. All right. A list of hop objects representing the route to the desired destination. A hop has the same properties as the host, but it also has a distance. All right. So what's a host? The host is also an object that is available. When you perform a ping, it returns you a host. So let me just quickly bring that up over here. All right. So if you perform a ping, one of the functions of this ICMP, it will return you a host which has the following value. So it has address, minimum. I think this is called the time to live. This is the average. This is called the round trip time. So this is the minimum round trip time, the average round trip time, and the maximum round trip time. So whenever you perform a trace route, it shows you what the minimum, average, and maximum round trip times were. Or this is the minimum, maximum, and average round trip times were to that particular router or something. So that's what we need to essentially figure out over here. So let's just go ahead and get started. All right. So I'll create a new file, And we first need to do, all right, I'm going to call it traceroute map.py. All right. And first things first, we need to do the ICMP protocol. All right. So what does, very fortunately, they have given us some examples, I believe. So we'll just take those examples and we'll go ahead and execute those. All right. So I have the traceroute example. All right. So let's say from ICMP import, I think it's ICMP lib. From ICMP lib import ping traceroute host and then hop, right? These are the objects that I most require. To perform a traceroute, I'll just basically copy this entire thing. All right. So to perform this traceroute, I do need an address. All right. What do I mean by address? I mean, let's just make sure that we accept this as a parameter from the system. And for that, I'm going to import the sys library. And if len of sys.argv is less than, if len.sys.argv is less than 2, then I can just say print need website as parameter, and then I can just say sys.exit of 0. All right, so it exits right there. Next, what do I need? Address is equal to sys.argv of 1. There you go. So now I have the address. What is count? So count essentially is, let's just look at the definition over here. The number of ping to perform per hop. Okay. So this is defaulted to 2. So every time you do a trace route, you need to perform a ping to the next server. And this is the number of pings to do for every hop. This is the interval time between each hops. All right. Ideally, we don't want any interval, but we'll just leave this as default. Timeout of 2. I think this is 2 seconds of timeout. We don't need this ID parameter. So this is a process ID that I don't need. First hop is equal to 1. Basically, we are assigning an ID of 1 to the hops that we are going to perform. All right. You'll see this in just a minute. The maximum number of hops that you need to do. Usually when you do a trace route from the command line, the maximum number of hops is, let's say, 64. I think, so there you go. So when you do a trace route from the command line, you will see that it says trace route to YouTube, 64 hops max. So if there were 128 routers in between you and youtube.com, you'll have to increase the map, you'll have to increase the hop count, or you'll have to, or else it'll just basically, after 64 hops, it'll just say, I couldn't find the route to the destination. All right. So that source is equal to none. I'm not sure what source is, but then we can look it up. So there's ID, first hop, max hop, source, the IP address from which you want to send packets. By default, the interface is automatically chosen. So so default none, we'll just let it remain as none. Fast is equal to false. We don't want to use the fast algorithm. And then the last one is some extra parameters that you need. So that's the traceroute command. Now I can just say results is equal to traceroute dot, and this is basically just all of the hops, right? So I'm just going to say that the return value is in hops. So let's just see what's there in the hops, right? So for hop in hops, print. What do I need to print? I'll say hop.address. Remember that when we looked up when we looked up the return value, a list of hop objects, the hop has the same properties as the host. So we need to look up the host, but it also has a distance. All right. So let's not forget the distance, and let's just very quickly look at the host. So the host has address, the minimum I keep forgetting round trip time, average round trip time, and the maximum round trip time. Now, the only thing that I'm actually bothered about over here, or the one that I'm most concerned with is the average round trip time. So I'm going to use that. I'm going to print that. So that's the address hop dot average round trip time. And then it also had a distance, right? I'm not sure what's in the distance, but let's just look at it. So let's just look at this very simple program that we wrote in Python, right? So that would be Python 3 traceroute.py. Oh, need a parameter. All right, let's say code space.site. This is not going to work because it says socket permission error. So basically what this means is that, I mean, what happens is that the ICMP lib over here, it creates a socket, and you need to be like basically a root to perform this, at least on on Linux. So the best thing to do over here is to use the sudo -e. The -e option ensures that all of your environmental variables and everything are intact when it performs a sudo, when it performs this root operation. So yes, so here we go again. Need a password for this. So right now it is performing the trace route. Hopefully my IP address hasn't changed. And no, it hasn't changed. So it should have finished that trace route. Let's just see what happens. I am going to fast forward through this one. So there you go. So the distance over here just prints the hop distance. I'm really not. Oh yeah. So there you go. So there's 8, 9, and then there is 11. What happened between 9 and 11? Essentially what happens is, let's say I perform a very pure traceroute function. I mean, this is something that I forgot to tell you. Let's say I do this. Oh, all right. So it did actually do it. So let's say if I was to do www.codespace.site. So if I did this, in between this traceroute, you'll see this star over here. It basically means that it wasn't able to get the router that was residing over there. And why is that? It's because whoever was routing it from this location in Maharashtra to outside doesn't want to reveal what their internal network structure looks like. So that's why a lot of network administrators will ensure that the ICMP protocol is essentially not allowed on their servers. This is to ensure that they don't reveal what their internal network looks like. So yeah, so there you go. So it's performed the hop across I think this way, it's the Atlantic Ocean, and then it found something on the other side. All right, so there you go. So it performed these, so to codespace.site, you can see that it skipped 10 over here. So this is exactly what you see over here. So over here also you see the same thing. So it went to Maharashtra, and then I think it hopped somewhere else. So anyway, so it hopped those steps, right? So 4, 5, so 5, 6, 7, 8, we are not able to see. Basically, it means that we don't know what their network looks like. And then it reached its destination. So that's what we need to do, right? So yeah, so that's perfect, right? I mean, we already have the address, we have the average round trip time, and then we have the distance. What can we do with this? First things first, we can convert this address into a latitude and longitude. But before we actually convert this into a latitude and longitude, we need to ensure that this is compatible with our query. What do I mean by query? Now let's look at the data once again for just a second. And you will see that all of my IP addresses, the IP addresses over here look like long integers. So your IP address is essentially converted into a long integer, and that long integer is the one that you can use to query in this particular database. So all you need to do is take this address, which is basically a version 4 IP address, into an integer. How do we do that? We can use a module called as the IP address, and I'll just show you how. So now I can basically say IP address string is equal to hop.address, which will basically give me my IP address. I can then say IP address. Basically, this is an object, and I can say IP address dot this one, IP address dot IPv4, where is that? So IPv4 address of this IP address string. So now I have this one. All I need to do is convert this into an integer. So I can just say IP address integer. Let me call it long because that's essentially what it is. Yeah, so I can just say int of IP address. All right, and let's just print this out. IP address long. So let's just print it out and let's see what happens. So I have this command ready. So let's say I do this, and you can see that it returns me a list of all of these objects, right? I'm sorry, not objects, these long values. These long values are the ones that I'm going to query against in the database to give me a latitude and longitude. So let's do just that. All right, so I have this, so that's my distance, and I have an average round trip time. All right, perfect. Now what do I need to do? Basically, this long address, I need to convert into, this long IP address, I need to convert into a latitude and longitude. And for that, I'm just going to basically query the database. How am I going to query the database? I will just basically execute this query on the database and see what it returns. All right. Let's just take one IP address from here. Let's say, for example, this one, and let's see what this returns. And you can see that it returns this. Let me execute the full command, or let me look at all of the rows and see what this returns. And you will see that this is already in United States, California Mountain View. So it hopped from Maharashtra all the way to Mountain View. Oh, did it go the other way around? No, it did actually go over the Atlantic Ocean. Anyway, so it did actually reach over there until it reached its destination over here. So anyway, so I have that. Yeah, so you can see that, you know, this is what the full thing looks like, but I don't need that. I only need this query, which I'm going to sort of declare as a variable over here. I'm going to say lat-long query is equal to so and so. However, this is going to be %s. It's going to be a dynamic parameter that I'm going to execute. Now, before actually before we actually do this, we also need to establish a connection to the database. Now, like I said, this is actually residing on my server. So this is, so if I was to just tell you what the connection looks like, you will see that this actually goes to my website, and this is where my server resides. Now, if you don't want to use this database approach, what you can do instead is use some kind of geolocation service which given an IP address will return you a latitude and longitude. They both essentially will perform the same thing. However, if you are interested in going this approach, I will leave a link in the description to the CSV database, to the location of the CSV file, which you can import to a local database that you have. All right. The thing over here that I'm almost not mentioning is that I do not want to give access to this database to everyone. All right. So how do I go about achieving that? So I have over here a database.ini file, which has all of the connection details required to connect to the database. All right. Now the ini file has a specific heading over here. I'm just calling it database details. You can call it whatever you want. And then I have the host, the database name, the username, and the password. All right. How do I read this ini file? I can read this using the config parser that comes, I think, built into Python. So what I'm going to do is I'm going to say config, which is basically a variable, is equal to config parser dot config parser. This is just to initialize it, and then I can say config dot read, which will basically read a file. In this case, I'm just going to put database.ini. All right. When I actually upload this to GitHub, I'll make sure that the database, the password is removed and everything. God, I hope I don't forget to do that. All right. That being said, now how do I read all of the values? All I need to do is say, all right, so that's the heading and these are all the variables. So all I need to do is say host is equal to config of database details of server host. All right, so that's my server host. Username, which I'm going to say uname, is equal to the same thing. Oh, I'm sorry. Yeah, let's just call it DB name. DB name is the same, except I'm going to put DB name here. The same goes for username and password as well. So I have username, which is this, and then I have password, which is this. So I'm going to put this in PSSWD. All right. So these are all of my config variables that are required to connect to the database. All right. Why am I going through this INI step route? Because I don't want to essentially reveal my database password. So how do we connect to the database? We are going to be using py-mysql. I think it's, yeah, so I'm not sure how to pronounce this, py-mysql, which I think is an inbuilt way for Python to connect to the MySQL database. All right. So we're going to establish the connection once. And after we have established the connection, we can like basically execute that select query as many times as we want. And let's connect to the database even before we have performed the trace route. All right. So we can probably put a print statement over here saying connecting to DB, you know, which will basically signify that we have, you know, and let's just put performing trace route, right? So that we know basically at what step the program is in. So how do I connect to the database? I can just basically say DB connection is equal to, so yeah, py mysql dot connect, right? Yeah, so py mysql dot connect, and for this I need to give the host name. So the host would be the host that I have read over here. Yeah, so which means all of this code needs to be at the very beginning. All right. So connecting to DB would actually open the parser file, would open the config parse, the INI file, would fetch all of the values and start performing the connection. Host is equal to host, and then user is equal to uname, and then pass WD. I believe it's pass WD is equal to PSSWRT. And then finally it would be the DB name, right? So DB name, I believe, would just be DB is equal to DB name. Yeah. So yeah, so that should essentially connect us to the database. So once it has connected us to the database, it should perform a trace route and then, you know, print everything. Let's just test this out, see if this actually works. So there you go. Yeah. So it did actually correctly connect to the database. Now you will see that I have not disconnected from the database anywhere, but I'm not really worried about that. You know, at this point in time, maybe when I'm improving this program, I can like close connection. But I'm basically relying on MySQL to close, you know, stale connections at a later point in time. So there you go. So now I have connected to the database, performed a trace route. All I need to do is run that query every time, you know, run that query, right? So let's run that query. How do we run that query? I can say with db connection dot cursor as cursor. So this basically gives me a cursor object, and over here I can say cursor cursor dot execute. I can give the lat-long query, and to this I need to pass a parameter. What is that parameter? It's basically this IP address long. So I have this IP address long. So this would execute it. And I can say rows, which will basically give me the rows as cursor dot fetch all. So this would fetch all of the values back. Do I need yeah, I'm just a little bit worried about the print statements. It does seem to be a little bit all over the place with the print statements and everything. I'm just thinking, what can I do to improve this? So let's just put everything into the same print statement and see what that looks like, right? No need to indent here. Can just put this, and I can say something like querying hop.address yeah, let this be, yeah. So it'll just basically print out querying this address, and then it'll print the IP address long. So it'll fetch all. So now I can say, all right, so what do I do with this fetch? Let me just create two variables over here, which is basically lat, and I'll just declare it as nothing. And then I have the long. which is also basically just an empty string. So that's my latitude and longitude. Let me just declare them as zeros. All right. And I can say for row in rows, lat is equal to row of 0, which is basically the first column, and longitude, should I call it long? No, because long looks like a keyword. I'm going to call it LNG. So anyways, so of 0 means the first one and of 1 means the second one. So I now have the latitude and the longitude queried. All right. So you will see that I'm using a for loop over here. This is just in the off chance that this query returns more than one rows. All I'm essentially doing over here is that whatever the last row is, that would be assigned the proper latitude and longitude. So now I have the latitude and longitude. How do I now convert this latitude and longitude into, let's say, an X and Y coordinate? I don't know. That's actually quite, it's actually quite a difficult function all by itself. So I looked up the internet and I have this function over here that can convert a given latitude and a longitude to an X and Y position on the pixel. Now, first things first, let's just put this on our, on our Python file. Let's create it as a function. So I'm going to create it as a function, and I'm going to call this lat-long to xy. All right. So it defines itself, or the method name essentially defines what it is. And to this, we basically need the map width and the map height variables. What are these? These are essentially the size of the of this image. So let's just go to properties. So this is 2521 by 1260 pixels. So let's just copy this and define them as the size of the variable. So I'm going to create a couple of constants or semi-constants. I'm going to say map width is equal to this many, and map height is equal to 1260. Right, basically half of 2521. So there you go. So that I also need to use the math function. So let's just import that module. So I have the math module imported, and I have a latitude to longitude xy. So let's just very briefly look at how this function works. Calculating the x position is actually quite easy. Now, if you look at the latitudes and longitudes, let's just look at them. All right, so I have, so this is the geographic coordinate system. So let's just look at what latitude and longitude is. Latitude essentially defines the y variable, and longitude essentially defines the x variable. All right. So if we go back over here, so longitude is the x, and this is essentially very similar to the map function that we have been using in JavaScript. So it just defines this longitude as it's a very simple definition, but the latitude is actually a little bit difficult, because you'll have to understand that the globe is essentially round, and that is why we need to perform this complex operation over here. So we need to perform a tangential operation of perform a math.tan of this result, which instead gets translated into a log, which will give you the proper y location. So this would give you the x and y location of. All right, so now that we have that defined, let's just use it and get the xy coordinates from a latitude and longitude. How do we do that? All right, so first things first, I notice is that I'm declaring these latitude and longitude as strings, which won't work because they have to be float values, for the lat-long function to work. So I'm converting them into float. To convert these into float, I just have to sort of, use this float function and convert them into float. So there you go. So now basically I have them as float values. I can now have the pixel locations. I'm going to call them xy location is equal to lat-long to xy, and I can say lat, lng, and let's see what this returns. XY log. So now I have the XY location already defined over here. All right. Do I need to print the latitude and longitude? Yeah, let's just print it. Let's see what happens. All right. There you go. So there you go. So it gives me a proper X and Y location that needs to be on that image. Before we go any further, you know how I was talking about, I'll have the MySQL database close the connection all by itself, you know, detecting that it goes stale. Let's not rely on that. Let's actually close the database. I can say database connection.close. So let's just call it manually so that it properly closes the connection. All right. So now that we have the latitude on the longitude and the X and Y location, all that remains is that we now put this onto an image, right? So how do I put this onto an image? Very fortunately, Python comes with this very interesting module called as the PIL module. All right, so it's called the PIL or the pillow module, which allows you to perform image transformations, load an image, create an image, write an image to a disk, you know, draw a line on top of it and everything. So let's just see how. Oh, there you go. So there is a very simple example that they've given over here. So we can do that, right? So I can. So let's just import that. I can say from PIL import the image and the image draw classes. All right, so I have these classes from the PIL module. All right, first things first, I need to actually open the image and then keep it in memory. So just as how I'm connecting to the database and then performing the trace route, before we perform the trace route, let's just open the image also. So I can say print opening image. How do I open an image? I can say image is equal to image dot open, and I can basically give that image as parameter. What is the name of my image? I think I called it world map. Yeah, so it's world space map. All right, yeah, I'll just leave it at that. So I'll have this world space map. So I also need to perform drawing operations on top of that. How do I perform drawing operations? I can use a function called as drawer. All right, so I can say image draw of image. So this will actually perform draw operations on the image and it returns me a drawer object. All right. What does the drawer object contain? The drawer object is the one that has all of the drawing functions. So if I went to the image draw module on this website and I looked at all of the functions, you will see that it has the arc function, the bitmap function, very much like the canvas thing that we've been using. But the one that we are most the most that we are worried about is this line function. All right, so let's use that and see what happens. So now I have the drawer object. All I need to do is start drawing it on the image, right? So I can say, I'm sorry about that, drawer.line. So I can start giving an XY, which is basically all of the X and Y coordinates, this X and Y coordinates that I have fetched. All right. And you'll immediately, and let's just look at the definition of that XY again, right? Of the line function again. So you will see that it requires pairs of X and Y variables. So basically line from and line to. So we need both of those over here. Okay. So for that, I need like a previous location also. So because the current location, basically because I have to draw a line, I must draw a line from its previous location to the newest location that I have fetched. How do I do that? Let's just create variables here called previous X and previous Y. So I have the previous X and the previous Y values over here. And now I'll create the values for the current X and Y location, which is basically XY location of X. I mean, if you look at this, this is actually an associative array with the X and Y values. So all I have to do is start drawing from the previous X, previous Y, X, comma, Y, correct? So yeah, so that's all that I need the line to be. So that's its locations. There is also a variable over here, a value over here called fill, and I can say fill is actually an RGB. Let's just draw it red for now. So I'll say 255,0,0, which is basically, the same RGB values, which is red. And then there is a parameter called width, which is basically how thick do you want this line to be. For now, we're going to start with 4. So that's my drawer.line, which will basically, draw the line. What happens after I have finished drawing everything? I mean, I'm basically done, right? I can just say image.show, correct? So this will just basically show the image on the screen. Let's just see what that looks like. I mean, we are, I think we are there, right? So we'll just let this finish. So it fetches all of them, queries everything. Oh, so there you go. So that's immediately you will see that there is a problem. First things first, I mean, we are not assigning previous X to anything. That's number one. And number two, you'll see that the first query starts from this middle location. That's because when you do this 192, when you perform 192.168.1.1, that's most likely your machine. This machine that connects to the server, and that will obviously return a latitude and longitude of 0, 0. So we'll need to basically account for that. All right. So what we'll do is first things first. So I have this. If, I mean, I'll say if latitude is not equal to 0 and longitude is not equal to 0 after you have performed this operation, only then do this entire drawing line. So that we can do. All right. So there are also situations where you're, all right. So we might not want to draw the line the first time around. Why is that? Because the previous X and previous Y would be 0. So they will start from the very corner. So we can add a condition over here saying if previous X is not equal to 0 and previous Y is not equal to 0, only then draw this line. All right. So once we have drawn it, we need to assign previous X and previous Y to their appropriate value. So I can say previous X is whatever current X and previous Y is equal to Y. All right. Think we are there. Let's see what happens now. Performing traceroute, querying everything. I think the query part is the one that takes the most time. So there you go. So that's the actual traceroute. Let me make this map a little bit bigger, and you can see that it actually traces out the route over here. So it goes all the way from Chennai to Maharashtra, and from Maharashtra it actually performs a hop. It actually performs a hop right all the way to California Mountain View, I think. All right. But does it actually do that? No. Remember those stars that I was talking about? I mean, where, somebody doesn't reveal what their internal network looks like. So it most probably hits somewhere over here, and then we don't see a couple of hops, but most likely this is what your traceroute will essentially look like. All right. To, let's say, youtube.com. What does it look like if we were to hit, let's say, my own site or our site here? What's this? Python 3, of course. What is the name of the file that we gave? We say traceroute map.py codespace.site. So let's see what happens here. So it performs a traceroute, but this traceroute generally takes a little bit time because I think this internal routing that happens is a little bit slow. All right, so it performs this traceroute. All right, so there you go. So now it starts querying it, which is great. It performs this one. So this shouldn't even go anywhere outside the country at all. Now I know for a fact that our server is located somewhere in Karnataka. I'm not entirely sure where. But you can see that the traceroute actually does that. So it goes all the way from Chennai to Maharashtra because it hits the geo network, and then it goes to our server, which is probably located somewhere in Karnataka. I'm not entirely sure if it is in Bangalore but I know that it's somewhere in Karnataka. So there you go. So that's actually how a traceroute, how this beautiful traceroute works, right? I could probably make the line a little bit thinner, so I could do that. So that was for a local server. All right, so it basically goes only within India, so it checks out, right? I mean, if it is going to youtube.com, it does go to YouTube, and then it goes elsewhere. What happens if we were to hit, for example, bbc.co.uk? All right, which I know for sure is somewhere in the European continent. So let's see what happens now. Boy, that traceroute takes a little bit time to do, right? Oh yeah, there you go. So good, good, good. We're there. All right. Oh wow. Oh wow. So this trace route hit from Chennai to Maharashtra, then it went all the way to Indonesia. Is that Indonesia? And then it bounced back and it went to, wow, it went to Mountain View, California. So maybe that's where they host their servers. I'm not entirely sure where they're hosting their servers, but that's what your trace route essentially looks like. Okay. Yeah. So that's what it looks like. That's what the trace route does. It's a very neat way to visualize what your trace route is doing, or you know, or how geographically all of these things work. Yeah, so the BBC probably hosts it over here. I'm wondering if I can do one more. Let's look at some Russian website. I don't know. Ministry of Agriculture, Russian Ministry, government.ru. All right, this should definitely go to Russia, right? What is it called? Government. It's government.ru. So if I was to hit this. Oh my God. So there you go. So that's actually the trace route for government.ru. It does hit somewhere in the Russian Federation. Let's say it goes from Chennai to Maharashtra to tries to take the Pacific route. I'm not sure. So this is somewhere in Indonesia. So it hits Indonesia, and then it hits the United States, hits Germany, I think this is, okay, this is Sweden, Norway, and yeah, this is, okay, one of these Nordic countries, and then it finally hits the Russian Federation. So you can see how many hops it has taken to actually go this route. All right. That was very interesting to find out. Very good, very good. All right. So that's all I had for this week. Thank you so much for joining. Thanks for subscribing. And if you can tell your friends, hit the subscribe button, put a like on our video, leave some comments, give us some ideas for our episodes. That will be great. It would help us along. Thank you so much for joining.